Hi, this is Christopher Maloney. I am talking to you today about plasma in your microwave, something we should not do because it will fry your microwave pretty quickly. Let me just present this to you. Plasma in your microwave, something we should not do. Here we go on. Here's the video. This is a very short section of
Almost 8 years ago, when this channel was fresh and before I had gray hairs in my beard, in fact, before I had a beard, I made a video showing that if you take a grape and cut it almost completely in half and put it in the microwave, you can make some plasma.
Oh, go the laws of physics.
Yeah.
Oh, yeah, it's still going.
So that's plasma in the microwave. You can watch that whole video at some point. It's microwaving grapes makes plasma. But moving forward,
Almost 8 years ago.
So what happens with plasma is, of course, photons. Photons are what you're currently using to see me. They're visible light spectrum photons, but they can also be photons that can be given much more energy. And so you can have photons. The same photon can make radio waves, can make microwaves, can make infrared, the heat that's coming off your body, ultra visible light rays, those are all coming off of us, and then X-rays and gamma rays. And then you get into, when you activate a photon so much, the energy that comes off of it actually turns the air around it into plasma. So that is what's happening. But it's all the same packet of energy, the same photon that goes through the whole process. So this is photons. This is what happens as you gradually get more and more energy, and what's happening is the frequency, the vibration of that energy goes up. So imagine a sound going. That's all the same instrument. It's all the same process, but it's different sounds, different levels of energy coming off. This is the refractive energy of the grape. And this is the second part why those grapes actually are able to make plasma, is that the grape itself is actually bending the microwave inside itself. It's actually bending it back and around. The way to think about this is to actually look at the refractive index of, sorry, technical difficulties here. Okay, the refractive index of water. We all know that water, if you look at that pencil, if you're in class, I'd bring it around to you. That pencil looks like it's broken in the water. What's actually happening is the light, the photons of the light are actually bending in, as we see it, the light is bending in the water, and we're seeing it as it's broken. It also looks slightly magnified because the water glass is round. We'll talk about magnification at another time. But the bending of the light based on the refractive index. So that's what's happening inside the grape as well. It's bending the microwave. There's also a process that happens in the back of the grape that's actually total internal reflection. So you can see this turtle. You see the water above it is actually a mirror, because the light is actually reflecting back. That's what mirrors do as well. They reflect light back at you. So when you have total internal reflection, you basically don't lose energy out the end of the grape. You actually have it bouncing back at you consistently. But that isn't enough to make plasma. You need something else that's called resonance. So here we have multiple versions of resonance, but the one that I watched in class is the Tacoma Bridge. That's a great video to watch. I would recommend watching the whole thing if you're very interested. We'll watch very briefly.
Oscillating in one of its natural modes of vibration with a period of 5 seconds.
So that's the Tacoma Bridge. It actually shook itself to pieces because it was at the resonant frequency. The air was sounding at 42 miles an hour constantly, and so that was the resonant frequency of the bridge. All things have a resonant frequency. You have crystals and other things in class. We worked with crystal glasses. That resonant frequency is the second part. It has to have that reflection. It has to have that total internal reflection, and then it has to have a resonant frequency that actually matches the frequency of the microwave. And that's what's helping build up that level of energy to make plasma. That's how they induce it. So here's actually the FPHD experiment that allows you to get a PhD and then study grapes. These guys are actually thinking about using it for energy source. So it's the kind of thing where you can take a very low energy, a microwave, and you can actually upgrade it to a higher energy. And there's our plasma ball that we worked with in class.